Let's start with a couple of the problems that gave me difficulty last time that I said I would look back at.
Okay.
And 20 was the first one. Let's talk about 20. First of all, that is not an XY coordinate. That is the X values that satisfy the domain. In other words, anything from -8 to 12, including -8 and 12, are in the domain of f of x. So, the only thing that affects domains is horizontal transformations, not vertical. In other words, if I have a function like this, and I take half of that function, notice that that does not affect the domains at all. It affects the range, but it does not affect the domain. So the first thing you need to understand is that domains are not affected by vertical transformations. Now, what's the vertical transformation in this?
1/2.
So we can ignore that. What's the horizontal transformation?
-3.
You need to say 3 right or 3 left.
3 to the left.
To the right.
It's
Remember, prior to calculus, everything is always x minus h or y minus k. And you are still prior to calculus. Okay? So if the standard is x minus h, then h is positive 3 in this problem. So I have to move it 3 to the right. What does that do to that domain? If I take that domain and merely move it 3 to the right, what do I get?
-5, 15.
That's what I think the answer is. Is that what your answer sheet showed?
Let me pull it up real quick.
Okay. If that's not the answer, then I don't know how to do this problem. Seemed to me last time you said D.
Yeah.
Okay.
No, it's C.
Okay, good. All right, great. All right, let's look at the other problem, which was on, Vault. Hold on a second. Sometimes you hit the wrong key, and you close out the thing that had all of your files on it. Let's see, Zachary Allen is how I found this. And it was test 2, where the other problem was that I was stumped by. A lot of times in math, if you give yourself just a little bit of chance to look at it, you can figure it out. But for me, it's hard in real time. It just is. I mean, trust me. There's a difference between doing it in real time with a student and having 5 or 10 minutes to look at the problem. All right. First of all, let's talk about inverses. Okay? So
Okay.
I'm going to call f of x the function, and I'm going to call f negative 1 the inverse. So if I tell you that this is true, then what do you know about the inverse? There's only one thing you know. Oops.
X and Y switch.
Minus 1, yeah. So what's the bottom line have to be?
F of 7 equals 2.
F inverse of 7 equals 2. Always. You switch the domain and range. That's the domain, that's the range. In other words, you switch the x and y values. This is f of x is 2. This is y, or what it's equal to. And f inverse is always the opposite. It's like if I graphed that function, and now I put the inverse function on there, like that. No matter where I'm at on the blue function, let's say I get this point right there. So I have f of 1 equals 2. Well, if I look at the inverse function, the red function, that's the equivalent point. And f of 2 is going to equal 1. Always, no matter where I'm at. I can be here, 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 here. This is always a true statement. If f of A equals B, then f inverse of B equals A. Okay? So, now let's look at this problem. First of all, they tell me it's 1 to 1. Therefore, I can reflect the whole function over that line, y equal x, and get its inverse. If a function is 1 to 1, meaning it passes the vertical line test and the horizontal line test, then its inverse is going to be a function. You don't have to restrict the original function at all. Sometimes you have to restrict the original function in order to come up with an inverse function. But in this case, if it's 1 to 1, then the inverse. So what has to be true if that is true?
A has to be true.
No, just give me the expression. What? In other words, if that's true about the function, what's true about the inverse?
F inverse of 11 equals 8.
Good. Now, we know that f inverse is a function. Okay? So if I was graphing f inverse and I go out to 11 and I get a value of 8, well, how can f inverse of 11 equal 5? That would mean we would have another point right there, and that's not a function. So the only thing we know is true is f inverse of 11 equals 8. So we know that has to be true. We also know that f inverse is a function, and if that has to be true, then that has to be false. Because it's a function. You cannot have f of 11 equal 8 and f of 11 equals 5. You cannot have the same x value equaling two different y values. So this can't be true. only because we knew that it was the original was a one-to-one function, which makes its inverse a function. And in fact, when they even talk about inverses, they say inverse functions. So even if you have something like a sine curve, where that's clearly not one-to-one, okay? Passes the vertical line test, but it doesn't pass the horizontal line test. So the way they allow themselves to talk about the inverse is by restricting the domain of the function from minus pi over 2 to pi over 2. And now if I look at that, that's one-to-one, which means it has an inverse. So when you're talking about the inverse sine function, you're only talking about that part of it right there. But that's because we started with a function that wasn't one-to-one. In this problem 3, the function is one-to-one. So we know we don't have to restrict it or anything, that its inverse is going to be a function. It's going to pass the vertical line test when we apply it. All right. Don't get a whole lot easier. Well, actually they do, but this one is not easier. First of all, we have to figure out what this terminology means. That's strange terminology. Okay? I'm not sure I've ever seen it like that. But here's what it means. It means f of g inverse of not x but 5. In other words, I could have put an x in there, and that's what this means. But the fact that they said evaluated at 5 means when x is 5. So this is really what they're talking about, what I've written on the right. Now we need to work from the inside out. What's g inverse of 5? Looking at the tables, you're going to look at this table right here.
Before.
That's g of 5. What's g inverse of 5?
8.
Correct. In other words, g of 8 equals 5 based on that row right there. And that means that g inverse of 5 equals 8. So the inside is 8. And now is all we have to do is figure out what f of 8 is. What is f of 8?
17.
Bingo. There were two very important principles here. But notice that we've had 2 or 3 problems where this property of inverse functions is constantly being questioned. In other words, if f of a equals b, then f inverse of b equals a. It seems like they keep giving us problem after problem after problem that forces us to recognize that. So that's clearly one of the things you're going to be tested on. Okay? Read problem 5, and without doing any math, give me your best guess. Hold on a second. Go ahead, you think about it for a moment. Here's the picture. I'll give you a picture. You have a triangle. Its base and its height add to 20. What do you think the maximum area would be? First of all, what's the area of a triangle? Always start with the general formula, always.
It's 1/2 base times height.
Okay. Like I said, if you had to guess, and sometimes you're going to have to guess on these. We're not going to guess on this. We're going to figure it out. But if you only had 20 seconds left on the test, you'd have to guess. What would your guess be?
50.
Perfect. That is the right answer. And it's a common problem. If I say, design a rectangle with the maximum area given a limited amount of wood, in other words, you have a certain amount of wood and you have to design a rectangle with the maximum area, guess what? It's always a square. If you have to design a pentagon with the maximum area, it's always a regular pentagon. Not that I can draw one, but in other words, geometry tends to find maximum areas versus perimeters when it's a square or a pentagon or a regular hexagon or a circle. If I have, instead of wood, I have some sort of material that allows me to bend it, and I only have a certain amount of material, and I say build the largest corral you can possibly build, because I got a bunch of horses I want to put in there, it ends up being a circle. That's why a circle is the most perfect shape in the universe. It maximizes the area given a certain perimeter. Now, if you have to build it with right angles, like most people do, because most people have wood that is straight. You can't build a circular corral, but you can build a straight corral. It's a square. If it's a triangle, I would have been inclined to say it's an equilateral triangle. So that's a B and that's a B. In my maximum, which means 50 is not the correct answer. But let's figure out how to do this mathematically. I still like 50 as the favorite. Okay? Here's the equation for the area. Now give me an equation that says this.
Base plus height equals 20.
Now give me the equation we're trying to maximize, which is the area equation. Now make that area equation a function of only one variable. Right now it's a function of b and h. If I make it a function of one variable only, then all I got to do is I'll see that it's a quadratic. So all I got to do is find the vertex. And that's the optimum area. So what is A equal to? Once I try to get it in terms of one variable only.
So it'd be 1/2 h.
That's fine. I don't care if you do h or b. Okay, so we're going to put the h there. Now what goes here? We want b here, but we don't want it to be b. We want it to be a function of h. So solve that for b.
20 minus h.
Now we've got a function that we can maximize because we know we're looking at a quadratic. So it's a function of h, and it is 1/2 times 20h minus h squared. We'll simplify that. We get 10h minus 1/2 h squared. That's our area function. Now, if we were doing calculus, we'd just take the derivative of that, set it equal to 0, and that's our h value. Once you get the h value, you can figure out what the base value is and figure out the area. Okay? But this is pre-calc. This is not calculus. But we also are looking at a quadratic. So if we can figure out where the vertex is, we'll know what the area is. So what's the formula for the vertex, the x-coordinate of the vertex? Or in this, I suppose I should call it the h-coordinate. What's the general formula? When you have a quadratic and you're looking to find the vertex, and it's not in vertex format, it's basically in standard format, and you're trying to find the vertex, the easiest way is minus b over 2a. Okay? So tell me what a, b, and c are in this quadratic down here. What's a?
1/2.
Minus 1/2. Do not drop negative signs. There's an unbelievable tendency for students to want to drop negative signs. Cannot. What is b?
-10.
You see a negative sign in front of that 10?
Well, you have to put the minus on top.
No, b is 10. In other words, the only thing I might want to do to this equation is rewrite it as minus 1/2 h squared. I want to put that in front, plus 10h. So that's our function. A is minus 1/2, b is 10. What is c? Actually, we don't care what c is. Notice that the x-coordinate of the vertex is minus b over 2a. All we need is b and a. So what is this? What's minus b?
Minus 10 over 2 over 1, -1.
2a is -1, so the h coordinate is 10. Well, now if we know the h coordinate is 10, the b coordinate is also 10. So 10 plus 10 equals 20. So indeed, we have a triangle whose height is 10, whose base is 10, and applying this, we get an area of 50. And frankly, that surprises me a little bit. I actually thought that we would get, I thought we would get an equilateral. This is not an equilateral triangle. In other words, this hypotenuse right there is not, it's greater than 10. Okay, so based on general mathematic or general geometric theory, you expect circles, squares, equilateral triangles, things like that. And this was not an equilateral triangle. Luckily, the answers they gave were all very far apart. In other words, if I assumed I was going to get an equilateral triangle, then there would be an answer slightly different than 50. In other words, it wouldn't be 10 and 10. Instead of 10 and 10, it might be 10, might be 9 and 11, where the height was 11, the base was 9. Then it still wouldn't be an equilateral triangle. It would have to be a base of 11, a height of 9, and that would give you a hypotenuse close to 11, and you'd have an equilateral triangle, and you get an area very close to 50. But they didn't put 47 on there. They didn't put 53 on there. They put 50 only. So this is a great problem that your first inclination, your first guess, is the correct answer. And I'm not suggesting you necessarily do that, but you saw how much math we had to do to prove it. So this is definitely would be considered a tough problem, and maybe ends up being a problem that you do guess on. Let me ask you this: when you take these tests, what percent of the problems do you end up guessing on? Is it half? I wouldn't expect it to be half. Is it 10%? Is it 20%?
Yeah, somewhere in there.
Okay. So you do guess on some, right?
Yeah.
Well, when you're going to guess, it helps to have a general idea. And the most general idea you could have would be a height of 10 and a base of 10, which would give you an area of that. And there's nothing really close to that. So I'm going with that instantly. I might, even if I was taking this test, I might not go through all the math to figure it out. Even though I got an answer that's not really what I expected, the fact is there's nothing even close to it. And I know that a triangle that is 10 by that is going to be close to a triangle where that was maybe 11 and 9 and 11 and 11. This is what I would have expected, but this gives you an area of 49. So it's still really close to 50. So there's no real need to do the math when they give you answers that are so far apart. It's got to be that, even though it's not exactly what I expected, but I know the answer isn't going to be 20 or 100. I'm going to have to shrink a little bit so we can see all of the answers. Wow, shrink it a lot. All right. Hold on, I'm not sure I shrunk it enough. No, I did. Okay, so there's only 4 answers. What they're saying is that this is f of x. Which one of these 4 is f inverse of x? And how do you know? All inverse functions. What is it?
B.
Okay, I don't know if it's A or B. It's one or the other. How do I figure it out?
If it like reflects itself over the x-axis,
Not the x-axis.
the y-axis.
No, not the y-axis. Over this line right here. That line is y equal x. Okay? So inverse functions are always reflections about that line. It doesn't matter whether you're talking polynomials, logarithms, sines, trig functions, or calculus. Integrals are inverses of derivatives. So every one follows this pattern, where the inverse is a reflection over the line y equal x. Not over the x-axis, that's the horizontal, not over the vertical, but over the line that has a slope of 1. That's a 45-degree angle right there, okay? So if you reflect their line, which we can barely see, over our red dotted line, you get, let me just try to do it. In other words, this distance, this point right here, has to be right there. This point right here has to be right there. Notice I'm reflecting it. And this point right there has to be right there. Hold on. What am I doing wrong here? I'm doing something wrong. So we're reflecting that line. So the reflection should look, let me just try to free draw it, like that. And wherever it crosses that line, we have to cross it. And then the other side should maybe look like, no, not quite. The other side should look like that. So, the other side is going to look like this. In other words, you always have to allow for the error of my artistry. Which answer is it? It's definitely A or B.
I think it's B.
You know, it's almost impossible to tell because, well, they don't give us any of these points. Let me expand it considerably. It's still not. Hold on. I'm still trying to figure out the difference between A and B. Well, the difference primarily okay, what do we know about that point right here? Let's do this. Let's learn everything. This point right there is 0, 2. So where's its inverse going to be?
2, 0.
Right here. Which graph is that, A or B?
A.
That's all we had to do was pick a point. They purposefully made that grid hard to read and didn't put a number scale on it or anything else, because it really meant we had to understand this principle that when you look at an inverse function, you're looking at the reversal of the coordinates. And so all I have to do is, that point right there is 2, 0. This does not have a point 2 comma 0 on it. That can't be the inverse. Always draw a picture when they're talking about rectangles and diagonals. So its length is L, its width is W, and its diagonal is 10. We don't know anything else. We don't know the relationship between L and W. Express the perimeter of the rectangle as a function of L. First of all, the perimeter of the rectangle is 2L plus 2W, right?
Mm-hmm.
Okay. They want it expressed as a function of L only, so we got to change the W. Well, what's the equation that governs those 3 numbers? Over here on the left, what is it?
A squared plus B squared equals C squared.
Give it to me in terms of L, W, and 10.
L squared plus W squared equals 10 squared.
Okay. Now figure out what W is, because we want to make W a function of L. And then we can plug it in down here, and we'll have our answer. So how do you solve this? This right here. It's the next step. Solving it for W.
Subtract L squared from both sides.
Now what?
Take the square root of both sides.
Now plug that in for this. So we have perimeter equals 2L plus 2 times what?
The square root of 100 minus L squared.
So there's our answer. Now we just have to find one that looks like that. So let me erase all of this so that we can see the answers. And some of this. There's our answer. We're looking at it. Now we just have to simplify it possibly, or make it look like maybe they'll have that exact thing on there. Do they?
Yeah, it's B.
They do. As with most of your multiple choice questions, the multiple choice doesn't really make it any easier. Almost makes it harder. Because you had to do this algebraically. You had to absolutely get to this point. And who knows if this is the answer they're going to... In other words, this would have been an easier answer if it wouldn't have been multiple choice. It turns out that they did put this exact answer on there, so we found it. But I might factor out a 2 and write this as L plus square root of 100 minus L squared and put that answer on there. And then I would have to recognize that this was the same as this. So sometimes multiple choice makes it harder, not easier. I haven't seen very many of your problems where we could back solve or anything. In other words, we pretty much have to solve the problem outright and then see if we find the solution. So, can you factor that?
Yeah.
Into what?
X plus 2, or not 2, 3.
The numbers have to multiply to 5. So you can't even be, they're plus minus. And these two numbers that I'm going to write here and here have to multiply to 5 always. So there's no way it can be a 3 or a 2. It's got to be a 1 or a 5. Now we do know that 1 is plus, 1 is minus. So our only choices are 1 and 5 or 5 and 1. Do either one of those produce that as a middle term?
No.
Okay, that means we can't factor it. And it's almost as important, especially at the kind of math you're taking, it's almost as important to recognize quickly that you can't factor something as it is, can you factor it? Okay? Now, the fact that we can't factor it means this can't be an answer and that can't be an answer. If either one of those were answers, we could have factored it, because those are the kind of answers that factoring it produces. The other three answers are produced by using what? How do you solve this if you can't factor it?
The quadratic formula.
Tell me what it is. The general.
Minus b plus or minus square root of b squared minus 4ac and all over 2a.
Okay. Tell me what A, B, and C are.
A is 1. B is 3. And C is -5.
I'll plug them all in and let's re-simplify this thing.
-3 plus or minus square root of 9 minus b, or plus 20.
Good. You're getting good at that. A lot of people might make a mistake there. Over what?
2.
Okay, does that give us enough information to answer it?
Yeah.
What is it?
A.
Correct. In other words, we don't really have to do anything more. We know that's 29. Good. If you were going to use index cards to memorize stuff, that would definitely be one of it. But it sounds like you've memorized it, unless you have a sheet of paper in front of you that shows you all these key formulas.
No. The last time we had to go over it. So.
Good. You definitely want to memorize it. How come my thing isn't working here? Hold on. It's because of this. Okay, now I should be able to do it. Cool, another good one. Tell me what the x-coordinate of the vertex is. It's a general formula. In other words, that's in standard format. It's not in vertex format. So it's not easy to know the vertex from the format that it's in. But we have a real simple way of figuring out the x-coordinate of the vertex. What is it? We had another problem today where we needed to figure out the x-coordinate of the vertex. What was it? Hint. First part of the quadratic formula.
B over 2a.
Minus b over 2a. Notice what the quadratic formula is. Minus b plus or minus b squared minus 4ac all over 2a. When I say the first part of the quadratic, I mean that part. And memorizing the quadratic should help you memorize that, and vice versa. Once you've memorized this, it should help you memorize the quadratic. Well, in this problem, the very first thing is to figure out the x-coordinate of the vertex. Now, they want the y-coordinate, but figuring out the y-coordinate is going to be real easy once we figure out the x-coordinate. Once we figure out the x-coordinate, we're just going to substitute it in for x and figure out what y is. That's y. Okay? So what's minus b over 2a?
So 16 over 7 over 2a.
What's 2a?
It'd be 8/7.
Simplify that. You divide a fraction by a fraction.
Be 2.
That's the x-coordinate of the vertex. Now, what's the y-coordinate of the vertex? In other words, what we want to figure out is what is f of 2? For that formula right there. Because that's the y-coordinate. In other words, once you get the x-coordinate, which you can get rather easily, then the hard part is plugging it in for x to figure out the y-coordinate. So what is it? What's this term?
Be 16 over 28.
No. X squared turns into 4. You're only multiplying the numerator. You don't multiply both numerator and denominator. Multiply numerator only. Minus what?
32 over 7.
Plus 3. We got to figure out what that is. Well, how many sevenths is 3?
21.
So I'm going to turn that into 21 sevenths. Now we have a common denominator. Let's just operate on the numerator. Our denominator is going to be 7. What's our numerator? What's 16 minus 32 plus 21?
Be 5.
There you go. 5 sevenths. That's the y-coordinate of the vertex. Finding vertexes from quadratics is always a little tricky. I mean, not tricky. What I meant was extremely important. There is nothing in algebra that you need to be able to do more than to find the vertex of a quadratic. Would you agree? I mean, you get, we do 5 problems a day. Well, 3 problems in an hour session we do, where we have to find the vertex of a quadratic. And the reason we have to is because we're looking for where the maximum is. In other words, if hold on, down to here. Another question regarding, here's what I was going to say. If you have a quadratic, it's a parabola. So it either looks like that, and if it looks like that, you're always interested in finding where that is, both on the x-axis and what the amount is. So the vertex is an extremely important thing, because if you have a function you're trying to find out the maximum, it's always going to occur at the vertex. Or if it's a parabola that looks like that, then you're always curious as to where that is. Where does the minimum occur? Well, in most of these problems, it's a maximum problem. And the reason is because that negative sign right there means the parabola opens down. So there is going to be a maximum if the parabola opens down. Whoops. What's the maximum number of inches a young oak can grow in 1 year? So, the number of inches a young oak grows in 1 year is this function. It's a function of rainfall, but it's still a quadratic function. So what they're asking for is where's the maximum of that quadratic function? If you plug that, are you allowed to use a calculator in all of these?
Yeah.
Really? So you could just plug that into your calculator and figure out the vertex, right? Or you could do it doing the way we've been doing it, using minus b over 2a. What's going to be easier here?
The calculator probably.
I don't think so. I think with the numbers we're looking at, what's minus b?
Minus 0.1.
What's 2a?
0.02.
That's 5. So given an R of 5, that's where you get maximum growth, is when R equals 5. In other words, we've just figured out the x coordinate of the vertex. Again, we need to figure out the y coordinate. So what do you do next? If you know the x coordinate, how do you figure out the y coordinate? Or in this case, we know the r coordinate, and we need to figure out the y coordinate, or the g of r coordinate.
Plug it in.
Do it. Minus 0.01 times 5 squared plus 0.1 times 5 plus 2. That is the answer. Now, you can use your calculator if you want, but let's not. That is minus 0.01 times 25 plus 0.5 plus 2. Well, 0.01 times 25 is negative 0.25. So negative 0.25 plus 0.5 is plus 2.5, 0.25 plus 2, 2.25 is our answer. C, between 2 and 3. In other words, they didn't even need you. This was a case where multiple choice actually helps a little bit, because once I get to that point, I know the answer. I don't even have to do the math.
Exactly.
2 plus a little bit. In other words, that's a little bit, that combination, plus 2. So it's got to be between 2 and 3. But again, it's giving you a quadratic that you have to find the x coordinate of the vertex and the y coordinate of the vertex. And we've seen at least 3 problems like that. So this is definitely something you're going to be tested on. There are some principles that they weight much greater than others. Make sure there's no E here. Ah, there is an E. Question is, which one of the following could be the equation of that parabola? Hold on a second. I'm not sure what's going on over here. This is not me to take a snapshot. Yeah. Okay. If you were in Vertex format, give me Vertex format. General.
That'd be b over 2a, or negative b over 2a.
No. Vertex format for a quadratic equation is what? I don't want the x-coordinate of the vertex. I want the general formula of vertex format. There's three different formats for quadratics. There's vertex format, there's x-intercept format, and there's standard format. You need to know the general formulas for all three. What's the general formula for vertex format?
X minus x1.
Nope, that's intercept format. There's vertex format. Intercept format is f of x equals, same a, x minus p, x minus q. P and q are the x-intercepts. In vertex format, h and k are the vertex. And in standard format, it's f of x equals different a x squared plus bx plus c. There's vertex format, intercept format, and standard format. You need to know all three of these. Everything we've dealt with so far tends to be in standard format. And when it's in standard format, that's where you use the minus b over 2a to figure out the x-coordinate of the vertex. Well, when it's in vertex format, you don't have to do any math at all. You're staring at it. What format is this in? Answer A. Is that in vertex format, intercept format, or standard format?
Vertex.
Correct. But is it correct for this point? Well, they've given us the vertex. What does it need to be? Does it need to be x minus 3 or x plus 3?
X minus 3, or, oh, no, x plus 3.
So that one's not any good. Those certainly aren't any good. So it's down to one of those two. What's the y-coordinate? Plus 9 in both cases. What's the difference between C and D?
1/4 and negative 1/4.
Which one is our function?
C.
No. This parabola points down. Therefore, A has to be negative. If A is positive, a parabola points up. If A is negative, it points down. Well, this one's pointing down, so it's definitely not that. Now, we think we know our answer, but just to be sure, we better put in this other point that they gave us here. Real quickly, I know it's over by a minute, but put in that point. If that point satisfies this equation, then we're done. So 5 equals minus 1/4 times 1 plus 3 squared plus 9. Is that a true statement? Well, that's 4. That's minus 1. Plus 9 is 8. Wow. That does not satisfy that. So we got to go back to the drawing board. Every one of these answers is in Vertex format. We'll begin with this problem next time. But
Okay.
the one thing you have to realize is that both of these points have to work in our final answer. Regardless of what we choose, they have to remain equations when you plug in these two x and y values. Both of them have to work. Okay? All right. Zach, talk to you next time.
Okay.